In this video, we're going to take a look at some enterprise application development considerations. So we're specifically looking at this from a technology stack perspective and doing a little bit of compare and contrast. I'll start with a Java interview question that I like a lot and I use a lot, and that is, what do you like about Java, and have you ever used this? And what do you not like about Java, and how do you work around this? Think about those questions, and also think about the structure of the questions. A lot of times when I'm doing an interview or when I've been interviewed, I've noticed that the questions often come in pairs. So there's oftentimes a fairly straightforward question and then a question that's a bit more of a deep dive. So straightforward question, what's your answer? And then the deep dive, were you really telling me a truthful answer? So what do you like about Java? A lot of times somebody will say, let's multi-platform. How have you used this? A lot of times the candidate will say, well, I haven't actually used it. What do you not like about Java? Somebody might say something like I won't say anything specific, but somebody might say something. Then the really important thing is, how do you work around this? Because if it's a limitation and you've used Java a lot, you must have found a workaround. One thing I encourage you not to say on what do you not like about Java, don't say, oh, it's great, there's nothing wrong with it. It's one of those things where when you get to know somebody well enough, you get to know their quirks as well as their strengths. And the same is true with a programming language. You'll get to know its quirks and its strength. So my answer to these questions when I'm in an interview, what do I like about Java? Well, it has a really big open source following, and there are a lot of things you get to choose from. What do I not like about Java? Well, because it has a big open source following, you have to make a lot of decisions. So it's kind of a double-edged sword. Now, we consider our friends over in Redmond and the Microsoft stack where you have C# and you have things like Visual Basic and Visual Studio. So this is an interesting compare and contrast. I've used both Java Technology Stack and Microsoft Technology Stack, and I've taught both the Java and Microsoft Technology Stacks. Both have strengths. In Microsoft, typically you're going to use the Visual Studio development environment, and if you're comfortable with a lot of the things that it's built in for you, like SQL Server, it's really easy to get an application up and running. But the trick is that typically if you're doing C# development, typically you're doing it on a Microsoft stack. So some kind of Windows Server, oftentimes SQL Server. You certainly could use other technologies there, but that's kind of the default. And if you're comfortable with that default, you can get an application up and running very quickly. So with Java, you have other decisions that you have to make. What IDE or development environment are you going to be using? What database are you going to be using? So the good news is it's easy to make these decisions, but the bad news is you have to make the decisions. So in this video, we're going to take a look at what some of those decisions are and the decisions that we have made for this course. We'll take a look at things like the development environment, or in other words, the IDE, some build tools, user interface, object instantiation, controller technology, and also persistence. So for integrated development environment, we really could use Notepad to write a Java program. And I remember very early on when I was learning Java in the late 1990s, the development environments, it's kind of funny to think of this now, but they weren't as good as they are now. They crashed a lot, in other words, and they were also expensive. A lot of times a development environment would cost you maybe $2,000 or $4,000 for a single seat. And so you could also just write Java using Notepad, and many times that's what we did. In my first few Java programs, that's what I used. Just plain old Notepad, not even the fancy things we have now like Notepad++. Shortly after that, there came out a development environment that was called Forte for Java, and then at one point it was called Sun 1. Now it's known as NetBeans. It was initially very much used industrial strength. Now you see it a lot in academia because it has a nice balance of complexity versus usability. You don't get very overwhelmed when you're using NetBeans. It's one of my favorite to use if I'm just doing something for fun. So now NetBeans is open source. Eclipse is also open source, so you can get both of these freely available. I see Eclipse in use in industry a little bit more now more than NetBeans. Eclipse can do a lot more and it has a lot of legacy users, but it is a very complicated user interface, in my opinion. So if you're just learning Java, Eclipse can be a bit too intimidating, and that's where I see NetBeans being a really good fit. Now, IntelliJ IDEA is a commercial product, so there is some license stipulation involved. There are community editions, and then there are also commercial editions. But I will say those who use IntelliJ IDEA really like it. And a lot of times what I've found is that something that would require you to click a button or do a hover over in Eclipse, it's just automatic in IntelliJ. Example, when you're going through the debugger, you have to look under the variables tab or hover to see variable values in Eclipse. But in IntelliJ, it just automatically shows it to you in line, which makes debugging really easy. Also, lots of good shortcuts. In our class, we're doing an industrial strength application, and so Eclipse is going to make the most sense, and that's the development environment we're going to use. Now for build tools, we have choices with Ant, Maven, Gradle, or just the Eclipse native build. Let's take a look at each of these. Ant was very common from about the turn of the millennia to maybe just a few years ago. It's something that can be used to build Java programs, but you can also use it just as a scripting language to maybe move files into folders or create new folders or things like that. It was very common. Everybody kind of knew how to do Ant. That was just one of those, oh, you just do an Ant script. It's XML based. It also lets you write some macros and allows you to do some management around bringing in libraries and the like. So very common. You don't see it now as much as you used to, but that was one that we all kind of knew for a while. Nowadays, we have one called Maven, which does a lot of the things that Ant does, but it can do it in less syntax. Maven is XML based, so you'll typically edit a file called pom.xml. One of the things that Maven does really well as opposed to Ant is dependency management. You can say that my application relies on this library version, and Maven will go out and it will automatically download that library version. If you need to change a version, you can do that in your POM XML file, and then Maven will get the update. So it works out really well. This is what we're going to use in our class. It is integrated with Eclipse. We just do a convert to Maven project, and we'll walk through that this semester. Gradle, this one's becoming common as well. We're not going to use it in our course, but it is frequently used in Android development. Very similar to Maven, but it has, I'd call it more of a JSON-like syntax than an XML-based syntax for its actual build files. But the other things that it does, like dependency management, somewhat similar to Maven. Now, there's also kind of the native Eclipse build where you can just do Java C. That's the default if we weren't going to make our project a Maven project. But in our class, we are going to use Maven for our build system. For look and feel, we have several choices. We can start with the good old XML and XHTML, which we're going to use in our class. This is what you learn from a normal client-side web development environment. And that's one of the nice things about the technology stack that we've chosen, is that these HTML files are largely going to be HTML files. Over the life of Java, we've had a few different options. We could write a servlet, which is a Java program that simply outputs HTML, essentially printing one line at a time. It's kind of clustered though, so it's not so easy if you want to make a massive site redesign. You end up editing code, which is not ideal. So the next generation that we had is something called JSP, or Java Server Page, which is where we essentially have an HTML page, but we could use a special syntax to inject Java logic into the page. From there we went to Java Server Faces, which was a kind of a newer version of JSP. It had easier ways of working with Java beans, or those things that are called getters and setters. I've taught this course with each one of these technologies in the past, Servlet, JSP, and JSF. Now we're going to move on to a more modern framework, one that's a bit newer, and that is we're going to use HTML and XML. We're also going to use Timeleaf. Timeleaf is something we can use with Spring Boot to take Java beans and make them available to our HTML pages. We'll use a little bit of jQuery to do an autocomplete on our form, and we're going to read a JSON source and parse that with, or actually use a JSON source and jQuery to do a little autocomplete where a user can start typing and it will suggest based on what the user has typed. We'll use some CSS, cascading style sheets. Also some Bootstrap. So Bootstrap is a library that puts together the best of CSS and the best of JavaScript to give you some predefined components. And then, of course, we'll use a little bit of JavaScript. Now, what's really interesting here is Timeleaf is Spring and to a degree Java specific, but if you look at the other items here, they're not. They're things that you could reapply in a Java-based course. You could put them on in a C# application. You could put them in a PHP application. So the nice thing about this course is that we're going to be using a lot of utilities that are not Java specific, but can be integrated with other disciplines. So you can reuse these across other technologies as well. Now, object instantiation, this is going to be a really big one for our course. Object instantiation means we are creating an object here, and we're saving it into a variable on the left. So far, we've learned object instantiation like so, where we declare a variable, and then we have an assignment statement, and then some type of instantiation on the right. But one thing is that you notice that the object type here is hard-coded. Now think about polymorphism. This is going to be a big lesson for this class, and probably in a few weeks you'll have this next line memorized. The variable type, which is this right here, tells you what methods you're allowed to call. The object type, which is this right here, tells you what will happen when you call those methods. So if that object type can change, that gives us a whole lot of flexibility because we can change behavior as needed at runtime. But to do that, we have to not hard code that object type. And that's where Spring comes in. Spring is really handy because the initial version of Spring, we could put our object type configuration in an XML file called applicationcontext.xml. And we still can do that if we wish. But there's a newer version or a newer way we can use Spring, which is called component scan, where it just kind of uses some naming conventions to determine what object type to wire up. And then we take component scan, we go one step further to something called Spring Boot. Spring Boot is really cool, and it's what we're going to use in this course. And with Spring Boot, the guiding design principle is don't require configuration for the most obvious default things. So in other words, you can fire up a website with little to no configuration and only configure what you want to configure. So if there's something where maybe you're not using a traditional port, then you make that a configuration. But if you're using the typical default port, there's nothing that you need to change. So Spring Boot lets us get these applications up very quickly by minimizing our configuration. A lot of neat stuff, and it's what we're going to focus on this semester. Controller. If you think about the traditional model view controller architecture, you have your model, which is essentially your representation of data. Think of this like a DTO. Then you have your view, which is the user's look and feel. That could be our HTML page with Timeleaf. And then our controller says, how do I handle button clicks? How do I handle navigation? Over the life of enterprise applications, you could hard code this. So you'd essentially have a series of if tests. But then changing navigation is very brittle and difficult to do. So you could also use struts or struts2, which had a controller. Very good. I use them quite a bit myself over my career. JSF has a controller. We've used that in previous versions of this class. But we can also use something called Spring MVC to define a controller by using a series of attributes. And that's what we're going to do in this class. A nice and flexible way to get some kind of controller logic into our application. For our database, we have several different options. So there's JDBC, which is where we're many times putting SQL statements directly in our code. But there again, if the database changes, we have to rebuild our code to match. And that can be a big process because it's not just compiling, it's also deploying that's important. Now, Hibernate is really handy because Hibernate makes it easier for us to take something like a data transfer object and just say, store this into the database. So Hibernate came along and it minimized our need for physical SQL statements. IBATIS, MyBATIS, very similar to Hibernate. In our course, we're actually going to use something called Spring JPA, which makes persistence just really, really straightforward. It's a little bit of these technologies that I've mentioned here, but It's very straightforward because you just have to define an interface and essentially set some variable types correctly, and then it's able to figure out a lot of the queries for you, and it gets us out of the business of manually writing queries and sticking them into our source code. Okay, database, this has kind of changed a bit over the last few years. For many decades, we considered a database to be a relational SQL-based database. And the big players there are Oracle, IBM DB2, and Microsoft SQL Server. And MySQL is a nice open source alternative, which is owned by Oracle. It is what we'll use this semester. A relational database assumes that we're relating different data together, and many times it serves as the golden nail that holds different applications together. The problem is, if one application wants to change the structure of the database, many times we have to upgrade the entire database, and many times that has dependencies on all of the applications that are talking to that database. So that central point of integration can have some benefits, but can have some drawbacks as well. One thing that we're seeing a bit more now is the advent of NoSQL databases. In a NoSQL database, you are essentially just storing documents, could be JSON documents, but you're often only storing documents that represent one concept. And this fits really well with microservices, where we have one application that just does one thing, and then we can tie together those microservices at a higher layer. So if you hear SQL versus NoSQL database, many times this is what that means. So our choices for this course: Eclipse development environment, Spring, Spring Boot, and Spring MVC is going to be our object instantiation and our controller, and also some configuration. TimeLeaf is going to take our Java objects and push them out to our user interface. Bootstrap, jQuery, JavaScript, and CSS, these are user interface frameworks that can be used across several technologies, and so we're going to bring them into our application. Maven for our builds, and then Spring JPA and MySQL for our persistence. So that's a look at our course this semester. Many very up-to-date and emerging topics. I'm looking forward to jumping in, and I hope you are as well. Thank you.